Welcome to the ninth part of Spring Boot with Kubernetes tutorial series. In this video, we are going to implement Bookmarks Search APA. Before starting implementation, let us first take a quick glance at what are the typical REST API guidelines for API URL patterns and what HTTP methods are supposed to be used. So these are not the hard and fast rules, but these are the highly recommended practices that is to be used while building the REST APIs. So usually when you think about any kind of operation on any resources, they broadly fall into these four categories, typically referred to as CRUD operations: create, read, update, delete. In our case, we are trying to fetch all the bookmarks, maybe based on pagination, or we might want to get one page bookmark by ID, or we want to search by some query, or we want to create a new bookmark, we want to update an entire bookmark, or we want to patch maybe few fields like title, we want to just update the title or URL, something like that, and we may want to delete one particular bookmark ID. So in such scenarios, these are the suggested HTTP methods to be used, and these are the URL patterns that we should be using. If you look at the URL patterns, you see there are no get bookmarks or create bookmark kind of a URL pattern, because the kind of a HTTP method that we are going to use indirectly refers to what kind of action we are going to do. Okay, so it is highly recommended not to use those kind of verbs as part of this one. So in our case, we are going to search, right? We are going to search bookmarks. So instead of again API/bookmarks/search or something like that, I recommend to use this approach where we pass query, whatever the keyword that we are searching, and also optional other parameters like page or whatever. So this is the API that we are going to build in this video. Currently, this is the API we have implemented to fetch the bookmarks with the pagination support. We are going to add search capability to the same endpoint because we are going to use the same /API/bookmarks ? Query equals to some keyword. So we are going to add the search capability to the same endpoint. So let us add this additional query parameter support. We are going to take an additional optional parameter which is called query. And one more thing is, usually whenever you want to support a optional query parameter, you can specify this request param name equals to so and so, and usually what other option is, you can specify required equals to false. In that case, even if you call this API without this query parameter, it's not going to fail. Otherwise, it's going to fail saying that query parameter is mandatory. One option is you can specify required equals to false, or you can specify a default value which automatically indicates this is an optional parameter. When you don't pass any value, whatever the default value that is passed is going to be applied. Okay, so in our case, query is empty, and let us bind it to a variable called query. So now what we can do, first we can search if query is equals to null or query.trim.length equals to 0, which means query is not passed. So in that case, we can simply return the earlier response, only fetching the data without filtering on query. Otherwise, what we can do, we can call another method, let's say search bookmarks, and specify what is the query and page number. So this method does not exist, so we are going to create a new method for it. Okay, now it is also going to be a read-only operation, so I am going to apply the same read-only equals to true on transactional annotation, and also we are going to prepare a same pageable argument because we want to order the result set based on the created at in a descending order. And again, only this repository.findBy method that is going to be changed. So first let me take a copy of this, and then instead of findBy, I want to search bookmarks. I want to call search bookmarks method and also pass this query. Okay, again this search bookmarks method is not yet created in repository. Let us create this one. So what we can do, we can take a similar approach of using DTO projection, and it's going to get longer, so I'm going to use this multi-line string support. Okay, here we are fetching the bookmarks, and let us apply the where class. We want to search based on title, and it should be a case insensitive search. And also we don't want to like start with or end with kind of search. The keyword whatever we are entering can be anywhere within the title, so it should be like search in anywhere. The keyword can be anywhere within the title. So what we can do to apply this in a case insensitive manner, I can use lower of b.title, and I can use like, and also I should lower the query parameter that we passed in, and also apply these percentages so that it can be a regex with containing option. So here, and instead of using question mark 1 2 3 like that, I prefer to use named parameter. So I'm going to use at query colon query, and I'm going to specify percentage. So in SQL, you know, right, sorry, we want to concat all of these. In SQL, we can use this percentage to indicate there can be any other characters, and then match with the whatever value we passed in, and also can contain anything else. So like that. So with this, we can run the application and see. So I'm starting the application. Okay, let me clear the log, and then I can reload. So this is normal API call without search. So here, if you take a look at, there is no where class. Now if I pass query equals to let's say boot, okay, only these satisfy the condition because the title contains boot. Again, if you notice, there is capital B, but we are searching in a case insensitive manner, so that's why it matched. And also it has boot here, here. So all the bookmarks with title that contains the word boot are written. Okay, let us check the log here. Here we can see it lowered the title, and also lowered this and applied this like semantics, and then applied the order by class. And here is interesting thing to notice. In our repository method, nowhere we mentioned the pagination part, but just passing this pageable argument this method, Spring Data JPA is figured, okay, we need to apply this pagination things like order by class, and then limiting it. So it is sufficient to pass this pageable to apply this order by class and limiting all that pagination support to whatever the JPQL we have written. Okay, cool. Right now, if you see, we call this method which has a custom JPQL query that returns the result. Spring Data JPA provides another mechanism to execute the queries. So instead of writing JPQL by ourselves, what we can do, we can create a method with a name that conforms to some Spring Data JPA conventions, so that Spring Data JPA itself can generate the query that we want to perform. So what we can do, okay, I am copying this. Instead of search bookmarks, we can start with, let's say, find by, and we want to search by title, right? We can give title, because this whatever the title name, it is nothing but a property in our entity. So here, this is the property we are referring here. Okay, find by title, and also we want to search using the like operation, right? So for like operation, we can use the keyword called contains or containing, And also here you can see IntelliJ is already suggesting contains ignore case. Also we want to perform case insensitive match, right? So we can use this. Okay, find by title contains ignore case, and we are passing this query. So what Spring Data JPA does is it removes this find by prefix and then try to build a where class out of this one. So here it checks whether the bookmark entity contains a property called title. Yes, it contains. So it's going to use title. And also considering this contains, that means it needs to apply like operator, not equal to operator. So it takes care of applying the like operator instead of equals. And then it sees this ignore case. Okay, it takes care of, okay, it should be a case insensitive search. Okay, so this way we can create a method name that automatically can be converted into a query by Spring Data JPA. Okay, so instead of using this method, let us call the other method. Okay, and let us restart. Okay, cool. If we okay, when we run this one, we got this no converter found capable of converting from bookmark entity to bookmark DTO. Okay, we got this error, and then based on I searched why we are getting this one, and what I figured out was here in our DTO we have both no args constructor and all args constructor. In this case, Spring Data JPA can't figure out which one to use to instantiate this one. So ideally we don't need this no args constructor. Okay, let us remove this no args constructor, and we have this DTO which contains all these parameters, and we have only all args constructor. Now let us see if we restart and then perform this operation. Okay, so now it is working fine, and it is also returning the exact same results as earlier. Now let us take a look at what kind of a query it is generated by Spring Data JPA. Here if we take a look at this where part, earlier we converted to lowercase, right? But Spring Data JPA prefers to convert it to uppercase, this title, and also use the like operator and upper of this question mark, and they take care of padding with percentages and also escaping the question mark, and also apply this pagination because we have pageable argument within the query. Okay, so this is very convenient, and it is really easy to perform some common operations. Like if you are using IntelliJ IDEA Ultimate, you can also see the suggestions, like it already shows what are the options available for this entity. You can see it gave auto completion for title, contains, and created it, and there are various options created as in, less than. So there are so many operations you can apply based on this naming convention. Okay, here if you go to Spring Data JPA documentation, under appendix there is this supported query method subject keyword section where it says what you can use. These are the prefixes, like we used find by, right? Similarly we can use read by, search by, things like that, and also we can check exist by or not, count by. So there are various other prefixes, and also you may want to apply different logical operators instead of simply equals. So in that case you can apply and, or, after, between, exists. So there are plenty of operator support. Just to give an example, let's say we want to perform a login operation based on username and password. What you can do, it is going to return a user, and you can say find by username and password, and give username password as value. So here Spring Data JPA strip off this find by prefix and then try to prepare a where class using where username equals to something and password equals to something. this keyword is going to be replaced with SQL and operator. So similarly, you can apply or something like that based on your use case. So you can refer this table, which contains a lot of useful operators that you want to perform. Okay, cool. So far we have been using this bookmark DTO, which is a Spring Data JPA's DTO projection support using class-based projection. Also, we can use interface-based projection. Just I want to give a view of how we can use, but it's up to you whether you want to go ahead with this class-based projection only, or you want to use interface-based projection as well. So let us just take a look at how we can use interface-based projection. So I'm going to create bookmark. I'm going to give it a name as view model, which is an interface. The naming convention is up to you. And here we don't define the properties, we define the getters for what fields we want to return. Okay, we want to return ID, title, URL, and created it. Okay, so ID type is long, so I'm having this get ID method, and get title, and we have get URL, and instant get created edit. Okay, so here you need to clearly understand that these are the properties we have in bookmark, and we just define the getters for those based on the Java Bean naming conventions. It should not be something different. It should be Java Bean naming convention based getters. Okay, so we have this bookmark VM model, and let us see in our repository. Let's create. Okay, for now what we can do, instead of returning bookmark DTO, let us simply return bookmark VM. Okay, and here let us use this one only. Okay, we are going to use this earlier search bookmarks only, but why it is giving error? Okay, so here it is not bookmark DTOs, it is bookmark VM. So right now we are not going to use, just we are going to call this method and see whether it is binding to this bookmarks page or not. Okay, okay, if I call this API endpoint, so here we can see now it has this bookmarks VM page and total 4 records and contains 4 records and pageable. So we got the result, and it bind to this bookmark VM interface, which is dynamically created proxy. And you can even take a look at this console. Okay, so this lower one is the method that is generated based on this search bookmarks, and find by title is the one generated by Spring Data JPA, and it is able to successfully bind to this bookmark VM page. Okay, so this way you can use interface based projections as well. Okay, so it is up to you which approach you prefer, whether you want to go with interface based projection or DTO based class based projection. It is up to you. Okay, cool. So that is all for this video. We have this search API implemented. Okay, stay tuned for the next video. Bye bye.